I can't tell whether I'm in. I can see my beard.
Yeah,
I'm in the picture.
Yeah,
We're like the Smith brothers of energy. Yeah. My coiffure. So I'm Wes Gollum, the energy geek, and I'm here today with my good friend Bob the Builder, Irving. Hi, Bob. Glad to have you back.
Yeah, thanks.
So recently, we just had a cold snap. It was minus 17 here. It must have been colder at your house.
It was. I had one thermometer that was about minus 17. The other one was minus 20. So that's the one I used.
Okay.
The minus 20 was on the west side. But anyway, we have 3 mini splits in the house. We have 3 condensing units outside because this is a several-year-old system, and we're doing 1-to-1. So we have 3 heat pump condensers outside and 3 mini split air circulators inside on the walls. And we have a 2,600 square foot house. It goes back into the 1800s, and it has been very drafty. I did fix it up a little bit, and when I decided to do so, I insulated it a little better. I did some work which I can talk about later. But during the cold snap, the kitchen has still heat loss from old doors and stuff. That got down to 64. Another room was closer to 68. This one is 20 below.
Yeah.
This one is 20 below. So the idea that heat pumps don't work in cold weather is nuts.
And now, since you put it in, they have higher efficiency heat pumps.
Yeah, the efficiency going up all the time. And you can run 3 units into 1 outside unit. So it's a much more efficient unit than it was just 6 or 7 years ago.
Can you explain why heat pumps are so efficient?
Yeah, because every other form of heat energy that we use in a house is you're burning something and you're destroying whatever it is to make heat. You burn up a piece of wood, you burn a gallon of oil, whatever it is. Once you get done with it, it's no longer there. It's burned up and it's in the atmosphere. With a heat pump, it runs on electricity, and what a heat pump is it's a pump. It pumps gases around a loop. A continuous loop. It's the same gas, pumps around and around and around. The house in the summertime on air conditioning is running exactly like the refrigerator. And the warm air that comes out of the bottom or the back of the refrigerator is what's coming off your condenser on the outside of your house running your air conditioner. And the cool air is taking the heat out of the indoor air, just like it takes the heat out of the indoor air of the refrigerator. Exactly the same thing. In the wintertime, it turns around, goes the other way. The gas turns around and goes the other way. That's the only difference. Same process, and works just the same. And now they've got them working to, well, they say 18 below, but I've never, I have a network of several hundred builders in New England that all build the same kind of houses, and we all use heat pumps, and nobody has ever said that they stopped working because it was too cold. So that's something I really don't think you have to worry about.
The efficiency goes down as it gets
The efficiency goes down. When it's really cold, you're on 100% efficiency, which is exactly what your baseboard electric radiator is, 100%. It's 100% efficient. When it's, say, 40 degrees out, and you want it 70 in the house, it's running at 300% efficient.
That's it.
300%.
You'll hear that as a coefficient of performance. And what that means is you're putting 1 unit of electric energy in, and you're getting 3 units or 300% of heat energy out. And again, that's way more efficient than, an oil system that in the end is, if the burner's 80%, it's
70% or 60% or whatever it is.
Right.
And gas is a little better. And wood, wood's a little better, but a lot of that heat goes up the chimney.
And all of those, including my beloved wood stove, and put pollution, put atmosphere,
into the atmosphere.
Into the atmosphere.
Bad stuff. The thing to keep in mind is that a toaster oven. If you have a toaster, you put it in, the wires get popped. Okay, your electric baseboard heat works the same way essentially. Heats up that piece of metal, and it provides heat to the room, to the toast, whatever. That's 100% efficiency. That's the best efficiency you can get using up any kind of energy, because that's as much as it will produce. With a heat pump, you're getting 300% because you're not converting the energy into heat. You're converting it into electricity to run the pump. So, maybe pumps will become more efficient and it'll be 400 or 500% better. But even so, the other side of this is that the better your house is, the tighter your house is, the cheaper it's going to be to run, the less often it will have to run. And that's really the difference.
So basically, a couple of comments on what you're saying, and I agree with everything you're saying. First of all, one of the houses in my book, Jack Bingham's house, he has a heat pump in the top of a greenhouse, and he was telling me on the days when it was 17 below the night before, it was over 80 degrees in his greenhouse, and he was getting a coefficient of performance not of 3, but of 6 or 8, and he's taking the heat out of the top of a greenhouse in the middle of February, and he's putting it into water and heating his.
And people say the sun doesn't work and the renewables don't work.
So let's put this into a bigger perspective of where this fits into the houses we're trying to build and retrofit and champion. And we talk about a 3-legged stool, and the heat pumps are one leg of that stool. The first leg is what you're talking about, efficiency, making the house, spending only as much energy as you need to get the job done. So lights, you're using incandescent or LEDs. Both will get the job done, but the LED is the efficient one. So everything we do in the house, we want to make it as efficient as possible. The second leg of the stool is your heat pump. And that is, we take a fossil fuel and we replace it with electricity. And just that, on average, just that saves about 1/3 of the energy that's demanded. And then the third leg of the stool is to produce that energy through a renewable, typically in New Hampshire, solar.
Yeah.
So,
and it's very possible in New Hampshire to run a house on entirely solar heat. A lot of people do it. A lot of the houses that I built do it. What they don't do is they are not, most of them, the ones that I built anyway, are not off the grid. They're on the grid. The grid is used as a battery. And if they had sufficient batteries around the house, they could do it without the grid. And I'm running into more and more people that are doing off the grid houses. It is doable. It relies, in the winter, there's not enough power to run the mini splits. So in the very cold days with a standard roof array. So you need more solar panels, or you need a better insulated house. That's the other half of this. And what the houses that we're building, the basic difference is that we're keeping the heat we make in the house, rather than just it's like taking a picnic cooler to the beach. And the old picnic coolers that were metal and a little bit of something on the inside, by noon things were getting warm in there. And now they're foam all around. They seal pretty well and they'll hold things cold for hours and hours. And that's the difference between a good house and a leaky house. I mean, it's the same thing. Good house is just tighter and it keeps the heat in. So do that, put the mini splits in, and you'll be more comfortable. The other thing is I'll mention quickly is in addition to air conditioning, they dehumidify. Most of the summer, we don't use air conditioning. We just dehumidify the air. And if the air is 74 degrees or 76 degrees and it's dry, it's comfortable. It's the humidity that'll get you. So we can turn on we have AC in the mini split. We can turn on AC or drying. We usually use drying. It's better. If it goes up to 95 outside, that's a different story. But usually it's really warm. We like it cooler in the house, and we just dry it off. There's a lot of heat that's carried in moisture, so you get the moisture out of there. the temperature actually drops.
Do you have any sense of how people can find a good installer?
Installers are tough. And 10, 12 years ago, there were very few. I called a lot of HVAC contractors when I started, and a lot of them told me they knew what it was, they'd never actually put one in yet, or they'd put in a couple, or they did a lot of them, or whatever else. And I contacted one company, and they said, "Oh yeah, we put in 5,000 last year, and we're doing 16 a week or something." And I said, "You're the guy I want. You know how they run. You got to know how these things work. They run with a gas in the pipe, not gasoline, but type of gas in the pipe, and so you need a refrigeration technician basically to work on it. And they have to understand the mechanics of it and the electronics of it in order to get it working well. So you want somebody with experience. What I would say is look at the websites for the dealers. Ask them how many they've put in maybe, or look and see if there's a recommendation from the manufacturer, which is usually based on the number of units they put in. It doesn't really rate the contractor, but if it's a Mitsubishi Diamond contractor, he buys more heat pumps than the guy that isn't. That's basically how it works. He gets probably a better price because he's buying them in bulk. And that's somebody that has to know what he's doing. Or they're going to go on fast if they have a lot of heat pumps that don't work. So you need a company that can service it. That's the one thing I'm stressing. Somebody that can service it. We've had very few problems. We've had the last 6 years. We've had very few problems. And when we have a problem, they come over. So it hasn't been an issue.
Great.
So I have a 2,600 square foot house, New Englander as they would call it. It goes back to the 1800s. Part of it's 1970s. Part of it's 1980s, early 80s. Different amounts of insulation. I've changed all the windows. So most of them are 3/4 of them are good quality double glazed windows, and 1/4 are the more recent final triple glazed window, which are much warmer on the inside. There's different amounts of insulation in different walls of the house. There's different amounts in various parts of the roof. So that all varies. The house is pretty tight. I've tightened it up. I put new weather stripping around the doors. I've changed the last 9 windows I needed to change, and did some things. I insulated the basement. And some people are going to say, insulate the basement. Nuts. If you're insulating a house, if you want to tighten up your house, if you want to make it comfortable, you have to insulate the basement. Otherwise, it's like walking around outside in the winter with no socks on. With no shoes. You need to keep the basement warm. Now, right now, your basement's probably warm because you got an oil burner down there, chewing up, drinking,
and because
100 gallons a day or whatever, burning that.
And because the earth is 50-55
and because the earth is 55
so it's a lot
degrees,
warmer
so
than,
everything's a lot warmer. But if you insulate, concrete is porous. The moisture gets in. It's also it absorbs heat. So any of the heat in your basement, if your basement gets up to 60, all that temperature is going outside. If the dirt on the other side of the basement wall is 50 and your basement is at 60, the heat's going out. So you really need to insulate the walls. You need to insulate the floor even more. You can do it. You can do it in old houses. I did mine entirely, the walls and the floor. And I stopped burning oil in my oil burner, hot air system. I stopped burning gas in my gas hot water system in a different part of the house. And I stopped burning 2.5, 3/4 of wood in my wood stove. So, and now I have 3 heat pumps. I don't have to do anything. It's great.
Excellent.
That focuses a little more on the insulation part. I think that's critical.
Air sealing and insulation.
Yeah.
Absolutely.
Yeah.
And I would put air sealing as number 1 with insulation
Yeah.
second.
Yeah. Yeah.
Great. Thanks. Well, thank you very much.
Welcome.
Good to see you.
Yeah, it's good to see you.